In the legacy modernization world, automated COBOL conversions used when our clients are looking to move away from the mainframe by extricating themselves from ancient procedural COBOL and pre-relational databases. The result is a 100% functionally equivalent object-oriented Java or C# application paired with a modern relational database that can easily be maintained and efficiently integrated with other apps and systems. Let's start with the technical challenges presented by a COBOL application and database transformation. You have a legacy application built in a procedural language. You want to move it to a modern object-oriented language, namely Java or C#. Most likely, the application's pretty important, or someone else would have rewritten it by now. The logic in this application could run your company's biggest software product, order fulfillment, or financial transaction system. Therefore, it's critical to maintain the business rules and functionality in the target state. However, since the application's so old, you may have trouble finding the proper documentation that details these rules. Ultimately, the success of your target state will be judged on how accurately it reflects the functionality and performance of the source environment. To emerge victorious, it's important to make sure all your bases are covered, from application code and logic to your plans for the data tier. So what are your choices? The easiest option is to maintain the status quo and do nothing. But as time goes on, there will be less available expertise and more money spent on licensing and MIPS that could have been spent on improving IT and delivery. You could always try a commercial off-the-shelf solution. However, they often come with standard business logic and workflows. Will they fit the processes and procedures that took your company more than 10 years to build? Often, enhancements to these types of solutions are so costly they overshadow the benefit of moving to them in the first place. Another approach is the Big Bang, or full re-engineering and rewrite of the application. This is the most expensive and risky approach, and the impact on end users in time to transition can be prohibitive. You could try rehosting, and that would alleviate some of the pain at the hardware level, but in the end, you're still reliant on ancient procedural code maintainable only by a shrinking talent pool capable of understanding it. This brings us to application and database conversion. The solution we're about to show you offers an automated way to convert applications and databases while maintaining business rules and full flexibility over the target hardware, language, and data tier of your choice. COBOL-To-Universal is our solution for transforming mainframe-based legacy applications and producing object-oriented Java or C# that can be easily maintained and efficiently integrated with other Java or C# applications. COBOL-To-Universal supports the entire COBOL application environment, including databases like DB2, IDMS, IMS, and vSAM. We also support CICS and JCL, and utilities like IDCAMs and SORT. COBOL-To-Universal is a fully automated solution that captures the entire source base of the application and automatically migrates it to object-oriented code. The resulting code has the exact functionality of the migrated application and can easily be tested and implemented into production. COBOL-To-Universal does not use code containers or emulators. We produce maintainable code that can be applied to a variety of target frameworks. The target code is generated with a full separation of layers using primitive data types. Data and code conversions are synced to ensure changes to one are reflected in the other as needed. Maximum performance is also a core principle of COBOL-To-Universal translation. We test on how converted code performs and build best practices for speed and efficiency into our conversion technology. A COBOL-To-Universal translation has 4 distinct phases. The first phase, Recover, is an automated collection and analysis of all the input code. This is where we inventory the legacy application elements and prepare them for translation. The Refactor phase generates the modern system's platform-independent intermediate language, and the Regenerate phase is where the intermediate language is converted to Java or C#. Lastly, the Refine stage leverages extensive pre-delivery testing to ensure the converted application meets project goals. Let's dive into each of these stages for more detail. We start with the Recover phase, where we import the source code of a COBOL application. The software analyzes the application and builds an XML repository with all the legacy artifacts. Now we can identify all the relationships between COBOL programs and databases, as well as screen and storage inventory. The data collected in this phase is critical for the success of the project. The recover phase is the foundation for documenting the business rules and functionality to be carried over to the target environment. Our interface allows us to export this information in easy-to-read charts, reports, and visual diagrams. Next, we move to the refactor stage. The goal of this stage is to ensure the target state works exactly like the source, performs the same or better than the original, and does so with maintainable and object-oriented code. This stage is fully automated to ensure accuracy and removes the chances of human error often experienced in application rewrites. We start by processing the XML artifacts repository and transitioning the procedural language to object-oriented code, producing a platform-independent language called OO rules. Prior to generating the target code, several areas are covered, including code structuring, where each COBOL program becomes a Java class, encapsulating working storage fields and paragraphs and exposing the main entry point as a service. Paragraphs become methods, go-tos are removed, and program flow is normalized. Program structure and comments are preserved, simplifying maintenance. We handle data remodeling, removing deeply nested data definitions by collapsing them to primary data fields. Redefines are removed, and transformations are done in order to use primitive data types. Lastly, we separate the database layer from the business logic, and data access and transfer objects are created for each of the tables, files, and vsam files. Now we're ready to generate the target code. Another advantage of having a platform-independent language is that once translated to OO rules, you can easily generate to multiple targets. We're able to translate to Java or C# with no code containers or emulators. We maintain separations of layers using Hibernate for the data layer and JSF or ASP-MVC for the web layer. Our solution also offers a variety of target frameworks. Prior to release, we subject the code to extensive automated testing and QA processes. This ensures our solution delivers completely accurate translations from logic and functionality all the way down to screens and user interfaces. From here, it's up to you what to do with your new application. With native, maintainable code, you can achieve full integration with outside systems for order processing, reporting, or business intelligence.